Hey science enthusiasts! Today I've got something truly mind-blowing to share. Dive with me into the quantum world of graphene, thanks to an incredible new development from the Weizmann Institute of Science. Introducing the cryogenic quantum twisting microscope, or QTM for short. This isn't just any microscope. It lets researchers observe the interactions between electrons and atomic vibrations, called phonons, at super low temperatures. It's like having a superpower to see the invisible. So why is this so cool? The researchers used the QTM to study twisted bilayer graphene. Imagine taking two layers of graphene and stacking them with a slight twist. At a specific magic angle, the layers exhibit bizarre phenomena like superconductivity and strange metallicity. The QTM revealed a unique low-energy vibration in this material known as a phazon. It's like unlocking a secret level in a video game. Here's the kicker. The stronger the coupling between electrons and these phasons, the closer we get to understanding these strange phenomena. This could lead to breakthroughs in quantum computing and new materials. How does the QTM work? It uses an ultra-thin van der Waals material at its tip as a quantum interferometer. It measures electron tunneling between the layers, where electrons emit a phonon. By tweaking voltage and twist angle, the QTM can map the phonon energy spectrum and measure electron-phonon coupling strength. But wait, there's more. The QTM isn't limited to just phonons. It can study various excitations like plasmons, magnons, spinons, and other fascinating modes in different quantum materials. This revolutionary research was published in 2025. So if you're as fascinated by the quantum realm as I am, keep an eye on this space. Who knows what other secrets we'll uncover next. Thanks for tuning in. Don't forget to like, share, and subscribe for more exciting science news. Catch you in the next video.